Psalm 19:1 says, "The heavens declare God's glory, and the sky above proclaims His handiwork," and that is what we are seeing here big time. That's, I think, one of the most fascinating and most important things about astronomy.
Dr. Danny Faulkner, good to see you again.
Same here.
And we had quite an experience in the Grand Canyon this summer. We really appreciate your participation, showing us the incredible skies above the canyon.
I was happy to be there. Thank you for taking me along.
And I guess you went on another trip already through the Grand Canyon. You're a busy guy.
Thanks to you, I was able to do it twice this year. Usually I do it only once. So I got double dip this year.
Well, it was a blessing, and we just had so much fun and learned so much. And I think the program came out really great.
Mhm.
And it just got done airing on TBN and YouTube and everything. So you're the big story, though. The Dr. Danny Faulkner quicksand cannonball stole the show.
That was fun.
All right, so we've done a series with you already on the universe, and I'm just so amazed at the beauty and the size of the universe, and that's your field. You know, you've also led us through Red River Gorge, and we've seen the arches of the east, arches of the west out in Moab, and we have an upcoming series because you're an archer, which is a term I think you created, and we have that series coming out, I think next year. But we've had a lot of programs with you, but this is one that I think we briefly mentioned, the Webb Telescope, when we interviewed you about the universe, and that was still maybe launching or about to launch. Well, now, you know, on Christmas Day it launched in 2021. It's up there, it's open, and it's been taking these images. So what's your just first take when you first started to see some of the imagery coming from the Webb Telescope?
Oh, they were very impressive. I guess I shouldn't be surprised, because when you build a telescope this big and put it in space, you expect it to look really grand. I do like to emphasize to people, though, this is a very different telescope. It's not an optical telescope like the Hubble Space Telescope is. The James Webb Space Telescope is way over in the infrared. That's longer wavelengths than we can see. We can detect some of those with our skin as heat. And the reason why they did that is because they really want to look at the most distant galaxies in the universe. And because of what we call the Hubble relation, or expansion of the universe, very distant objects, their light has been shifted from visible wavelengths way over into the infrared. So if you want to study the light coming from galaxies that normally would be in the visual part of the light spectrum, you have to go deep in the infrared. So all those pictures you see are truly false colors, but it still doesn't detract from how pretty they are. They really are incredible. They're not just pretty pictures, a lot of things you can learn by looking at those pictures. And they also take spectra as well. That's the thing that's not been talked about much yet, but that's even more important sometimes.
All right, so one of the big things that they wanted to do with this, because it is so powerful, is they want to look back in time. Now, our viewpoint is different, I believe, and because we have a biblical worldview, and we believe that all of the universe, the stars were created all at one time. So you really aren't looking back in time per se as much. But, you know, the time starlight takes to get here, they extrapolate from that of how old the universe is by how far back we can see. And I want to get to that. I want to get to when the Webb telescope was pointed at something that Hubble showed very blurry, like disorganized and small, and what they actually found and what the scientists are saying about that is really, really amazing. But let me first go back to, let's say the telescope was just open, the pictures first were appearing, and I want to play you a clip from CBS News. They were doing a story on the Webb telescope. And we'll stop it and just kind of get your comment along the way. So we'll just comment on this.
Okay.
Whether you're a space nerd or a casual stargazer, you have to admit NASA's new collection of deep space photos is astonishing. Check this out.
Okay, we'll stop there, Danny. Are you a space nerd or a casual observer?
Oh boy, I'm not a casual observer by any means. I guess people would call me a space nerd. I've been
You're a space nerd. I'll just
been in astronomy all my life, so I guess I am.
You have a Ph.D. in this field, so you certainly know what you're talking about. So I just wanted to get that out of the way.
Okay.
They come from the agency's James Webb Space Telescope, which is designed to look back almost to the dawn of time, and it's helping answer some big questions about how our universe was created.
Okay, I'll pause there. What do you feel about that statement? This telescope's going to help us look back in the dawn of time.
Yeah, the assumption is that the Big Bang is how the universe began 13.8 billion years ago, and that the light then from the most distant things you can see would be 13.8 billion light years away. You can't see any farther than that because there was nothing that existed prior to 13.8 billion years ago. And according to that idea, the Big Bang, the universe began in a very hot and dense state. And as it expanded and cooled, it was very bright at first. Then it got dark, what astronomers call the cosmic dark ages, for a few 100 million years after the Big Bang. And then stars began to form, and that relighted the universe. So you now had cosmic dawn, a reawakening after a few 100 million years, and soon galaxies formed from that. That's the whole idea. So the hope of the James Webb Space Telescope was to see back to that cosmic dark ages, and that's what he's talking about there. And of course, this would suggest it was a time you're looking back where there were no galaxies, no stars. We're going to take a different approach to that. God made the heavenly bodies on day 4, and he proclaimed at the end of that day it was good, and the end of day 6 it was very good. And that goodness talks about completeness, fulfillment. Things are functioning as they were intended to be. So my expectation based on that is that we're going to see galaxies all the way back. We may reach a wall, but we're not going to see this point where there's no stars and galaxies. That's my expectation. But the expectation within the normal paradigm of Big Bang is you will look back to a time where there won't be any stars and galaxies.
Daunting in scale, 7,600 light years away from Earth, the Webb Space Telescope's jaw-dropping image of the Carina Nebula details stellar birth in our own galaxy.
All right, so just give me your first impression of this image when you first saw it. Again, the infrared, you're saying, is creating some false color, but still just a beautiful image.
It is incredibly beautiful. It kind of reminds me of some of the Hubble Space Telescope images. Some of those were false color too. But the Eta Carina Nebula, the distance he gives is about right, nearly 8,000 light years. Truly remarkable object. You can't see it from where we live, though. You have to be in the southern hemisphere to get it very high in the sky. And it's one of those really cool things you can see in the southern hemisphere. I tell people God put all the good stuff down there. But it's a complex thing that's going on there. The Eta Carina is a really interesting star that's exploded in the past, blown off material. But nearby, there's a nebula associated with it. And this is one of the places in the sky they think is a stellar nursery. They have to believe that stars are continually forming. And so they look out in space for regions that might fit that idea. And this nebula is one of those things that they think is a stellar nursery.
The big question, I think, with the Big Bang is what exploded, right? And so even if you hold to that cosmology, you would still have to answer that question, because out of nothing comes nothing. Isn't that the big problem with the Big Bang?
I think so, ultimately. Now, the Big Bang is not really an explosion. That's unfortunate. The name comes that way. It's just basically the sudden appearance of matter, energy, space, and time. People have a hard time grasping this, but the concept of before the Big Bang doesn't make any sense, because time began with the Big Bang according to the model, and space didn't exist either. So it's truly a start of everything. But the universe coming into existence, you suddenly have this appearance of matter and energy, and that would violate the first law of thermodynamics. So the universe, if it began that way, came into existence in a manner that's grossly inconsistent with itself. I mean, there's a nice contradiction there right away. It's like, asking, can God do everything? Well, there are certain things that God cannot do. He cannot do things that are contrary to his nature. God cannot lie, for instance. And the Big Bang, the universe, should exist in that sort of manner as well. It can't come. I don't think it can come into existence in a manner that's inconsistent with the laws that seem to govern the universe. So yeah, I think it's a huge problem. The very beginning of the universe really is.
Every dot of light we see here is an individual star, not unlike our sun. And many of these likely also have planets. And it just reminds me that, our sun and our planets and ultimately us were formed out of the same kind of stuff that we see here.
All right, so comment on that.
Yeah, she said that these stars that you see there have planets. Well, we don't know that. We haven't seen them. She's extrapolating from the number of exoplanets we've discovered in the last 25, 30 years. We're now up to over 5,000. It seems likely that many of those stars would have planets, but to say they definitely do is a bit of a stretch. But then she makes the comparison that our own solar system, our own sun and planets, they formed out of the same sort of environment there. And that's the assumption of naturalism once again. If you don't believe in divine creation, then the universe had to create itself, then it had to create stars and planets. And that's what she's talking about there. And that's the ruling mythology or creation myth that is found in astronomy today. The Big Bang followed by galaxy formation, followed by star formation that's ongoing today. None of this is really proven, of course. It's just conjectured, and they try to find pictures and images that are consistent with what they're trying to put forth.
And she also said that's where we came from, meaning, the humans came from all of this.
Yeah. Many times people think that evolution is all about biology, just biological evolution, but there's also geological evolution, astronomical evolution, cosmic evolution. It's all part of the same package.
And some people say you're just stardust.
Carl Sagan was very, very fond of saying that. He first said that probably over 40 years ago. I don't know if he originated that, but he certainly popularized it if he didn't. And I hear it repeated quite a bit that, the idea is the Big Bang begins with just hydrogen, helium, and a little bit of lithium. So where did the calcium in our bones come from? Where did the iron in our blood come from? Where's the nitrogen and oxygen we breathe and makes a large part of our body? The carbon, which life is based, where did all of these things come from? Lawrence Krauss wrote a book about a decade ago about a universe from nothing. And about that time, he was giving some lectures, and he talked about this thing about being made of stardust. And he said, and please forgive me for quoting him here, but he said, forget Jesus, the stars died. To make it possible for you to be here. So he was, kind of mocking the central truth of Christianity, that Jesus died for us as a way to give us eternal life. And it's kind of sad that he did that, but that's the idea of stardust coming up once again.
And he is the bright and morning star, and he did die for our sins. So what's the mistake then of Christians adopting the evolutionary models like the Big Bang?
I think they have difficulty separating the naturalism that's there, that so many scientists have, from study of the natural world. I do believe science, which is a study of the natural world using the five senses, is a very God-honoring sort of thing, particularly when we study the world as it now exists. The problem is so many scientists want to speculate about what might have happened in the past, and before they begin, they eliminate the possibility of there being a creator. So they have to make up some sort of naturalistic answer. I tell people when you believe in naturalism, when you come up against something that has no natural explanation, like for instance the origin of the universe or the origin of life, well, you have to make up some sort of explanation for that. And it doesn't matter how illogical or how improbable it may be, it must have been what happened, because you've already eliminated a supernatural sort of thing, which creation would be. You've eliminated that from consideration from the outset, and so they're left with nothing but naturalism, and that's the problem. People like to say, "Well, you're creationists, you're anti-science." No, we're against the naturalism's assumption that so many scientists have. We actually agree with them on many subjects. It's just when we get the origins, we have a difference of opinion.
Yeah, and I read one article about people that were looking at the Webb's imagery and saying, wow, it doesn't really support their assumptions for, smaller, more loose galaxies and stuff like that. But then they said, well, people that deny the Big Bang are also flat earthers. They kind of combine both of those things together.
Yeah.
And I know that you're a flat earther. No, I'm kidding. You are very opposed to that just because of science. Of you can measure, and we know for sure the Earth is not flat. Someone like you, and for sure someone like me, because I'm not trained, but you're trained. You have a Ph.D., but you're still put into kind of an anti-science camp, I think.
Oh, I definitely am. They like to lump creationists with flat earthers and all of this stuff. And, this really illustrates, again, the problem we have. We talk about science in two different ways. One of them is the science of the here and now. Some people call that operational science, experimental science, observational science. We study the world how it now exists. The other is what's called historical or origin science, where you take some sort of scientific principles and try to apply them and figure out what might have happened in the past. Forensic science is a great example of that. You can use scientific principles to put together what happened in the past or might have happened in the past. You can't conclusively prove it because the past is past. And cosmogony, what people call cosmology many times, is history of the universe. And on it goes, historical geology. The rules are very different there. And I hear people sometimes say that discount or disbelieve evolution. It's like discounting or disbelieving gravity. The problem is we can test gravity in the here and now. We can perform. In fact, physicists do this regularly. And yet, how can you devise a test, an experiment that you can do that will tell you what happened, say, 100 million years ago? Well, you can't. So the principles are different. When they lump us with flat earthers, it's something that I've been opposing, as you well know. I've written a book on flat earth, and I continue to argue against it and try to point out where it's wrong. We can test the shape of the earth and size of the earth in the here and now. It's not a question of was the earth flat in the past. The question is the earth flat today? And the answer is no, it's not. But when it comes to about where the earth came from, how old the earth is, those are the kind of questions that normally we can't address in science, at least not the way science is done. So people confuse those two very different ways of doing science.
This image shows stellar death in the Southern Ring Nebula. A yawning cloud of gas and dust reveals a fading star, part of the universe's life cycle.
All right, so what he just said about the star dying, would you agree to that? I mean, can you observe stars that are actually weakening or dying right now?
Yeah, to a certain extent, I could. The example he showed there, the Southern Ring Nebula, that's an example of what we call a planetary nebula. It has nothing to do with planets. The name is kind of misleading. Many of the planetary nebulae we see have a kind of a disk-like appearance, which resembles that of a planet. So that's why the name from a couple hundred years ago came about. In reality, these are shells of gas that have been blown off by stars. If you look at photographs of different planetary nebulae, there's always a very hot star at the center. We presume that material was blown off in the past. The shell of material is expanding, and that seems to suggest a very, very strong inference that, well, it must have come off of that star in the past. Now, how it happened, when it happened, that's a bit of conjecture. It kind of fits in with some of the evolutionary models they have for stars. I don't think we want to go into the details of those today, but I do see an expanding gas shell off of many of those. So I have no problem with this being blown off. What will happen to the star next? That's another question.
This pinprick of light flashed more than 13 billion years ago.
And by going just a few 100 million years farther back in time with Webb, we want to see toddler galaxies and infant galaxies, things that are just forming.
Were you blown away?
Absolutely. They're fantastic, and they include something that is a deeper infrared image than has ever been taken in history.
Compare. Here's the Hubble's image of the Carina Nebula, and one more look at the Webb's.
All right, so any comments on that? Obviously, they just show the comparison between the nebula.
Yeah, they were kind of contrasting there at the end of that clip, the high resolution of the Carina Nebula and the kind of a fuzzy appearance of that other one. Well, one's only 8,000 light years away, and the other one, they estimate more than 13.1 billion light years away. Things that far away are going to look fuzzy. You're going to lose detail. The distance of that object is not really known. Eventually, they may be able to get a spectrum from it, and from the redshift, get a good distance from what we call the Hubble relation, which is how you get distances out there. It's a bit of overkill. And a lot of creationists may think, hey, yeah, this is great. Well, you gotta look at it more carefully. Some people who are critics of the Big Bang have run with this. And what it's really disproving are certain versions of what happens after the Big Bang. And I have every confidence that they will refigure their models and make them fit the new observations. That's what they've done in the past, which they're going to do here as well. It doesn't disprove the Big Bang itself. It just simply disproves a particular version of the Big Bang. And I think that's the route they're going to take. So we shouldn't get too excited about those kind of claims yet.
Certainly, the images are surprising scientists.
Absolutely.
Because that's what the stories I keep seeing, and I'm not even looking for them, is scientists are baffled. This image is different than they thought it would be. So again, I agree with you. I don't know that anything's ever going to deter them, but it seems to me that like the more powerful telescopes and microscopes we get, the more order, design, size we find in our universe, however far or however small it is. It's astounding how complicated this place is.
Remember what I said earlier about my expectation from the goodness of the creation? I think we're going to see galaxies all the way out, and that's what we're seeing. So I take kind of confirmation of what I believe from this, but they're going to have to tear up the models, secular models, the naturalistic models, and refigure them because there's a problem there. It's not been stated. They're not going to because it doesn't come from the images, but they're looking at spectra too. Remember I talked about the chemical enrichment, how that the galaxies, stars start with just hydrogen and helium from the Big Bang, and you have to create all the heavier elements, such as the ones that we make up our bodies. They're finding those heavier elements all the way back as well at that earlier time in the universe. This doesn't get talked about a lot. Now, I blogged about this about a month ago. They're finding evidence of oxygen and neon and other elements in quite a large abundance. And that means they're going to have to refigure their models of chemical enrichment as well, because the universe is getting too chemically enriched too quickly is the problem. And that doesn't really work with their model as well. Again, the creation model, the goodness suggests that it's complete and fulfilling everything it's supposed to. So I'm not surprised personally from this, but most astronomers are shocked to see this change.
And so this is the rocket taking the Webb. Very expensive. How much? Do you know how much this thing cost?
It's a few $1 billion. I can't remember.
Oh. And a million miles away from Earth, I understand.
Yeah, it's not in low Earth orbit like the Hubble Space Telescope was. And the segment of mirror had to unfold perfectly. And that sun shield you see there had to unfold perfectly.
Right.
If it went wrong at any step, the telescope would be ruined.
It is amazing. I mean, the feat that was accomplished is pretty incredible.
And that didn't happen by accident, did it? It took someone to design all of that. Yeah. Yet, I think the things we see in the world around us, even the James Webb Space Telescope, and yet people stumble over that and think it's just naturalistically going to happen that way.
And so this is one of the images.
Yeah, I believe that's Stephan's quintet. That's a very famous group of galaxies.
Quintet. The first image is astounded NASA Administrator Bill Nelson.
It's almost a spiritual experience.
So NASA's administrator says it's almost a spiritual experience. I would agree with him on that.
Well, absolutely. I think astronomy is more artsy than any of the sciences. And it's also one of those things that really stretches the imagination, like we find in Psalm 8, when David's asked the question, when I see the stars, the moon, who am I? Who are we that you would think about us? I'm paraphrasing very roughly there, but he was asking the big questions, and we're still asking the big questions. And I think astronomy, above all sciences, causes us to do that. So, when it starts getting you to ask questions about the fundamental meaning of life and the purpose and everything, that is a more than philosophical. That is a theological, if you will, a religious sort of thing, and it should cause you to understand that there is a creator, as Romans 1:19 and 20 tells us. We have a creator, and he's very powerful.
Almost a spiritual experience, because you realize that there was a beginning, and we have come from that beginning.
Deep space may answer deep questions, as Amber Strawn told us last December.
They're more than just arcane science questions. They sort of get to the heart of what it means to be human.
So I think that's exactly what you were just saying, and I'm guessing these aren't believers, but to come to that point of what the Webb is showing us, it does go to the very heart and soul of who we are and where we came from.
It really is something, this cosmic reach back to when stars first lit up.
The thing I really wanted to talk to you about is this Nature article, and I'm sure you're already familiar with it, and you probably already commented on it. And
right there.
Yeah, so, you have it. Yeah, so
I do.
More revelations from the Webb telescope about distant galaxies. What is your takeaway after reading that Nature article?
Well, again, it's challenging the paradigm we've had for a long time of not so much the Big Bang, but what happens next in the universe, how the first stars and galaxies formed, when they formed. And they're saying the 4 points they had was, one, is there's an awful lot of galaxies, more galaxies out there than they thought. That is, more galaxies shortly after the Big Bang. They thought it would take longer for this to happen. We're getting galaxies that are more distant than before. They've overlapped with Hubble and gone beyond Hubble. Third, the galaxies are complex. And that's another point I haven't mentioned. But we're seeing galaxies fully formed out there. They look a little different from nearby galaxies, but essentially they look like our nearby galaxies. They were expecting disk galaxies like the Milky Way to take a long time to form. Well, no, they're not. They're forming very quickly within their own paradigm. Hence, they have to change all of that. And then they're talking about overlapping with Hubble. They looked at a galaxy. Hubble was really pushed to its limits in the optical part of the spectrum. They look at the infrared, and the galaxy doesn't have the same size that they did from the Hubble. Why? Well, they're not quite sure. They're going to be figuring through that one. So big shocks there, and again, challenging the general paradigm. Not that they think the Big Bang is wrong, but the aftermath, how soon stars and galaxies formed, which I think many astronomers would probably want to separate out anyway from the Big Bang.
Well, the headline, to me, the thing that I caught when I read this was Alison Kirkpatrick, astronomer with the University of Kansas, Lawrence, said at the end of the article that, after all her years of study, she says, and after seeing the images from Webb, which I guess the Webb had been planned for 20 years, it took that long to get this thing.
At least, yeah.
It's incredible.
She said right now I find myself lying awake at 3 a.m, wondering if everything I've done is wrong. And what she's referring to there is that she specializes in very distant objects, in galaxies and galaxy formation and star formation. And so she's very quickly realized that the data they're getting don't agree with what she and other researchers that specialize in that field have been saying all along. So she's not saying that it's total rubbish. She's saying that, well, we've taken the wrong direction. We have to go back and kind of rebuild this model from the ground up. And unfortunately, some people have misunderstood that and misinterpreted. Eric Lerner was the one who primarily did that. And he had an article where they used the word panic, that people are panicked, and that was an overreaction, I think. But Eric Lerner has his own ideas to pursue.
Yeah, but it definitely fits with what you were expecting, and it doesn't fit with what they were expecting. So I think that tells you something, right?
It does. Yeah, I'm very encouraged with what I see. Yeah. I was encouraged when we got the first close-up of Pluto a few years ago. A bit surprised, but everybody, the people who with a secular viewpoint were saying, well, Pluto is going to be a heavily cratered world. Well, it wasn't. And so we continually get surprised again and again and again. We shouldn't be surprised we're being surprised all the time, should we? And that's probably the lesson from all of these things. But we have to continually, as advanced as we are, we have to continually tear up the old models and replace them with new ones.
Another article that says James Webb Space Telescope is spotting things that have scientists baffled. And so it's just, some of the observations are, this one says, James Webb's observations are also leaving scientists absolutely puzzled. The Space Telescope has been on the crash course to turn our knowledge of the universe on its head. So comments like that are pretty bold of how this is kind of shaking up the community.
I think astronomers in my lifetime have gotten extremely bold in their pronouncements of how the universe developed. The Big Bang happens, and then all this other stuff unfolds. And what the Webb telescope has told us so far is that most of those theories are not really viable anymore. They're going to have to redesign those because of the structure that comes up too quickly, the stars and galaxies that form too quickly, the element abundance that build up too quickly. They're going to have to completely rework that. And this continual process, I remember back 40 years ago in my education, the idea back then was that galaxies formed. You had a big cloud of gas that formed, and it slowly contracted down and formed a galaxy. Well, now they're saying, no, little bitsy areas come together to form stars that then amalgamate into bigger structures that eventually become galaxies. The first thing I mentioned was top down. This is bottom up. Totally different viewpoint. And in the last 40 years, it's completely switched. Now, will they go back to the earlier one? I don't know. Time will tell. But they keep tearing up the theories of how we came about. And again, I emphasize these are historical or origin science, not operational science, not the observations of the here and now. So it should be humbling for people. I don't know if they will be humbled, but that should be, because really there is a crisis here. And redoing all the models they ever had to explain how galaxies and stars came to be.
This article continues, for the longest time, scientists believed that the early universe was a place of chaos, a point in time when early galaxies were small and organized as the cosmos formed. However, with James Webb observing galaxies so far back in time, we can see that things were quite different. Galaxies were not only massive, but also less chaotic than originally predicted. Again, we've already said all that, but
fully formed.
That says
fully
that.
formed, galaxies all the way out.
Now, this is interesting. I don't know if you've seen this image. This is a more recent article. The headline says spellbinding new image. These concentric circles, it looks like, around a star. Are you familiar with this?
Oh, okay. These rings apparently were caused by eruptions from the star itself. We've known that for a while. We suspected that stars, certain types of stars, what red giants particularly do this. Actually, more stunning than I would have imagined. I mean, we can see in the line of sight of some of these stars in the spectra evidence of episodic ejections, but this is showing you actual photograph of those shells, and that is a stunner. That's I didn't expect that at all.
Yeah, this is saying the star is what is known as colliding wind binary.
Wolf-Rayet stars. Those are really hot stars, and they're different. They have emission lines from their spectra, and that's pretty rare. Most stars have just absorption lines. Wolf-Rayet stars have both, actually, but they're very hot and very enigmatic, very massive stars typically, and they are known for eruptions like this. So, but to see this in such great detail, that's quite shocking.
When we see these images, Hubble was really astounding people, but now this one is just taking the socks off people. If you have a creation perspective, we give more glory to God. Evolutionary model is scrambling. So I feel very confident about my faith that I just believe that God created us, and all this complexity and design is on purpose for a reason. We're not just cosmic accidents.
No, we definitely have a plan here, and Psalm 19:1 says, "The heavens declare God's glory, and the sky above proclaims His handiwork." And that is what we are seeing here, big time. That's, I think, one of the most fascinating and most important things about astronomy. When most people look at spellbinding pictures from astronomy, they see the beauty, they see the wonder. Physicists, astrophysicists, astronomers, we see some of the physical processes going on, and that's really cool. If it stops at the first step or the second step, it entirely misses the point. The real point is, as Psalm 19 says, it's telling us there's a creator, and Romans 1:19 and 20 says as well. The universe is a giant billboard advertising God's existence and the fact that He's powerful. But as big and as powerful as He is, as big as the universe is, and we're not much geographically speaking, but we are the center of God's attention. I raised Psalm 8 earlier about David asking, given the vastness of the sun, the moon, the stars, who am I that you would care for me? Well, he goes on to answer that question. He said that God is crowned with glory and honor. It goes back to what we are from Genesis 1. We are created in God's image and in His likeness. Nothing else in creation is described that way. So while we may be tiny in this vast cosmos, we are very central to God's attention. So central that God did a remarkable thing. He sent His own Son, Jesus Christ, into the world to become sin for us. He took the penalty of sin for us. And this brings us back to the really important questions of life, not only where we came from, who we are, but also where we're going. And Jim, it's important that people always hear that gospel message, that this God that made the universe stoop down to humble Himself, become one of us, to suffer, take our penalty for us. And through faith in the finished work of Jesus Christ, we too can be made whole with God and can enjoy Him forever. That's the really good news of the gospel, and that's the really good news and lesson we should be taking from all of this.
Amen. Thank you. And are you going to be using some of these new images from Webb in your presentations?
Oh, yeah. It'll take me a little time to decide how to use them, but yeah, I will be talking about them. I got a lot of my own photos that I like, but these are really cool. Yeah. I will be incorporating. Everybody will be eventually.
Right. Awesome. Well, thank you for your time. I wanted to get this out there because I just keep seeing these stories, not even looking for them. And I love it. Just to say, hey, we have truth and we don't have to worry about what the next telescope's going to tell us because it's all written in the book. So thank you very much, Dr. Danny Faulkner. Appreciate you.